All right, so in this video, we want to sketch these functions over here with different transformations, and we want to state the domain and range as well of these functions. So let's start with the sketch. This first question here is a rational function, basically a 1 over x or reciprocal function. And we know that the vertical asymptote is the solution of the denominator, which is positive 2. I'm going to have a vertical asymptote at x equals to 2. And the horizontal asymptote is at the c value, which is positive 1. So for reciprocal functions, we always draw our asymptotes first. And then the regular function would just be in this quadrant over here and this quadrant over here. But since there's a reflection over here in the y-axis, this thing is going to reflect and come onto this side, and it's going to look like this. And the one on the bottom here would reflect in the y-axis and will come to this side. So it would actually be over here like this. Now, if you look at this function, our domain is basically all real numbers such that it does not equal to positive 2. Basically, any rational function or reciprocal function will take all real values except for the vertical asymptote. And our range will be all real numbers such that it does not equal a horizontal asymptote, which is positive 1. Let's go to the second question over here. This is an absolute function, or basically a V-shaped function. So again, let's start with the sketch. For a V-shaped function, you always want to start with the vertex, which is basically the x value is over here, the opposite of this, which is positive 3. The y value is this, which is negative 2. So 3 and negative 2 is somewhere approximately here. And there are no reflections in this. It's all positive values, which means it's going to open upwards. And then we can label the vertex. So the domain of this function and all absolute functions is just x is all real numbers, because it goes towards the left towards infinity and towards the right towards infinity. But our range is all real numbers such that we know that our minimum y value here is negative 2. So y has to be greater than or equal to negative 2. Third question here is a square root function. So for a square root function, we always start with the starting point. The x value of the starting point is negative 3 and the y value is negative 2. So negative 3, negative 2 is somewhere approximately over here. And normally a square root function would go in this direction like this. But now we have a reflection in the x-axis, which means that it would normally be going up, but reflecting the x-axis means it's going down and towards the right. Our function would look like this. We can label the point now that we have the graph, negative 3, negative 2. So our domain for this function is all real numbers. And my minimum x value, this is the smallest x value, which is negative 3. X has to be greater than equal to negative 3. For my range, it's all real numbers, and my maximum value is negative 2, because this is the highest point. That means y has to be less than equal to negative 2. And last question here, we have a quadratic function. So for a quadratic function, we always start with the vertex. The vertex is positive 2 and negative 3. Oops, that's the wrong place. Positive 2 and negative 3 is down here. And this graph is positive, so it opens upwards. And similar to an absolute function, the domain is always all real numbers. And for the range, it's all real numbers and my minimum is -3. So y has to be greater than or equal to -3 is the range.